Hi there, my name is Miss Townsend and I love math. Welcome to Math with Townsend. This video is for grade 12 students in advanced functions studying the log functions unit. In this video, I'm going to be doing some solving of log equations. This is a by request video. I handed out a package of material to review and a few students wanted some help with question 26. So this is a video where I'm going to take up and solve all of question 26. Here are the questions. This is the first video where I'm going to do A, B, C, D, D, E, and F, and then I'll have a second video up where I do G, H, I, and J. All right, let's just jump into it and look at the first question. So here's question A. It says x equals log base 5, 125. Now, our goal is to solve for x, and x is already isolated. That means I don't have to do any algebra manipulation. All I have to do is evaluate what's on the right side of the equal sign. So I need to evaluate what is log base 5, 125. So this goes right back to the heart of what is a log statement. So what this actually says is if I have base 5, there is an exponent that would give me an output of 125. And what I would need to do is figure out what that exponent is. So hopefully you've done enough questions with exponents and that sort of thing, or you can probably quickly guess and check to figure out that if I put exponent 3 on base 5, 5 times 5 times 5 is 125. And that means, so this is an exponential form, in log form, that means that log base 5, 125 equals 3. So this expression is 3, which means x equals 3. All right, so let's move forward and look at B. So again, in this question, I'm solving for x, but x is already completely isolated on the left side. So let's just look at what's on the right, because that's what we need to evaluate. So what I have is two log expressions. They're both base 5, and they're subtracted. So because they have the same base, I can apply the properties of logs, specifically the one that says, if the base is the same and you're subtracting the two expressions, you can apply the property that allows you to rewrite it as a single log statement where you're dividing. So now I have a single log statement, and within this bracket, let's do that math. 225 divided by 9 is 25. So now I'm down to just this statement, and again, just like in A, let's review what I'm actually asking for here. What this log statement says is what exponent would have to be put onto base 5 to produce an answer of 25. Well, we know that 5 squared is 25, which means the exponent is 2. So log base 5, 25 is 2. So x equals 2 is the solution. All right, next one. So in this question, I don't have x isolated, but boy, it's going to be really fast to isolate it. So let's start by isolating x. This is a subtraction statement. So I'm going to add 3 log base 3, 243 to both sides, and then I'll look again at what else I can do with this expression. So again, I'm just starting by isolating because it's such a simple thing to do as a first step. So now what can I do? Well, you should notice that these two log statements that I'm supposed to be adding have different bases. Then that means I'm not going to be applying any properties of logs like we just did in the last question. And that means really the only approach to this is to evaluate this expression, 4 log base 2 root 512, and evaluate this expression. And then once I have their values, just add them together. So let's see what we can do here. So the first thing I notice here is that I'm taking the square root of 512. Well, because working in logs, it means that you're really working in exponents. You really want to change all of your root signs, be it square root, cubed root, whatever, into exponents. So that's the first thing I'm going to do, is rewrite that root as exponent 1/2. And now what can I do? Well, this 4 is multiplied by this log statement, and according to the properties of logs, I can rewrite that as an exponent on what I already have. And that means I can nicely multiply those two exponents together. And I'm just going to keep writing the second part here. We'll talk about that one after. so I'm not going to even look and see what I can do yet. So this is really log base 2 of 512 squared. And then again, I'm just going to keep rewriting this so I don't change the expression. So what can I do with this? Well, it's base 2, and I really want this to be evaluated. So what I'm going to do is I'm going to rewrite 512 as 2 to the exponent 9, because that's what 512 is. It's equivalent to 2 exponent 9. And again, I'm just rewriting this. We'll come to it later. So that is really, if I apply exponent laws here, that's really 2 to the 18. So have a look at what I have, and don't worry about the log base 3 part yet. I have log base 2 of 2 to the 18. And there's a log property that says, and I'm just going to write it over here, log base b of b to the x is equivalent to x. So that's exactly the situation I have here. I have log base 2 of 2 to the 18. So that's just equivalent to 18. So I've evaluated that. So let's come over here and look and see what we've got going on with this part. So I could take this exponent 3 and write it over here. The problem is it doesn't get me very far, because then I would have to somehow deal with 243 to the exponent 3. But what the heck, let's see what happens. 243 to the exponent 3. Now obviously I don't actually want to calculate what that is, because having a huge number isn't going to be very helpful. But what I can do is take 243 and rewrite that as follows. 3 to the 5 is equivalent in value to 243. So again, I now have this exponent law in play. So I can multiply that together. So x equals 18 plus log base 3 of 3 to the 15. And now exactly like what happened before, I have this situation again. I have log base 3 of 3 to the 15. So that's just equivalent to 15. So I end up with x equals 18 plus 15. So x equals 33. Done. Now, I should point out that at the point in each of these statements where I took the number out front and rewrote it over here, I could have not done that as well and simply multiplied. So let me actually show you what that would look like. What's the best way to do that? So I'm going to take this expression, see if I can get this. And I'm going to just create a new screen here, and let me show you how else we could have done this. Okay, boom. So I'm going to start the same way. I'm going to isolate that x. And while I'm here, I'm going to rewrite 512 exponent a half, and then plus 3 log 3, 243. Now this time, because I'm not going to move the 4 up to exponent land, instead I'm going to move the half into multiply territory. Those are just made up terms, by the way. Territory, I mean, I didn't make up the word, you know what I mean. So this is actually going to be a half times 4. That's actually going to be 2 log 2, 512, plus 3 log 3, 243. So now I'm going to leave times 2 in front and deal with this. And again, remember 512 was 2 to the 9. And over here, 243 was 3 to the 5. And what happens is I have this log 2, 2. That's going to disappear and leave me with 9. Log 3, 3. That's going to disappear and leave me with 5. So my next statement is 2 times 9 plus 3 times 5, which is 18 plus 15, which is 33. So both of those methods are perfectly fine, and they both use the properties of logs appropriately. All right, let's look at the next question. So in this question, we have x is within this base, or not within the base, sorry. X is within the output here, 2x plus 5. And so I need to isolate that. Well, the problem is that it's in the log statement. So what else can we do? Well, remember, what this statement says is that 5 to some exponent is equal to 2x plus 5, and it actually tells me the exponent. Oh, okay, hang on. I wrote the question wrong because I was about to do 5 exponent 220. I was about to do 5 to the exponent anyway. It would have been bad, and you'll see, hopefully you'll see why. Okay, so again, what, oh, I lost track of what I was saying and I don't want to stop the video. Okay, what this log statement says is that if you have base 5, there's some exponent that will give you a value of 2x plus 5. Well, and they told me the exponent. They told me the exponent was 2, so why don't I put 2 in this equation? So in other words, what I've done is I've rewritten my log equation as an exponential equation. And anytime that you know the base and the exponent, that's always a good approach. So because I knew the base 5, exponent 2, it makes more sense to change the log equation into an exponential equation. 5 squared is just 25. And now I'm just dealing with a linear equation. Solve for x, subtract 5 from both sides, divide by 2, x equals 10. So don't forget that sometimes if you know the base and you know the exponent, it's much easier to work in the world of exponential than log. All right, moving on to E. So you'll notice this is another question where I know the base and, well, I don't quite know the exponent, but neither of them are x. The first thing I want to do, though, is I want to get rid of this multiply by 2. So I could move it into exponent land, but it's a lot easier to just divide both sides by 2 to leave me with this log statement and equals 2. So I don't want to complicate my life by squaring a binomial. It's much easier to do this. And now I have the base and I have the exponent, so let's rewrite this as an exponential equation. Much easier. 3 squared is 9, so now I'm just solving a linear equation. So subtract 1 from both sides, divide by 4, x equals 2. Yay. All right, let's see what's next. Here's question F. So what do we have? We have, on the left, we have log base 12, a log base 12, and then plus 1. And over here we just have 2. So obviously I'm going to start by taking this plus 1 and subtract it so that I have all my logs on the left and everything that isn't a log on the right. And then I'm also going to say, okay, well, these are both base 12, and I'm subtracting. So I'm going to apply the log property that says that if you have the same base and you're subtracting two distinct log statements, you can write it as a single log statement by using division. And then again, don't forget this plus 1, I subtracted it to 1. So now what do we do? Well, I have the base and I have the exponent. So let's rewrite this as 12 to the 1 equals x over x minus 2. And now I just need to solve for x. So at this point, oh, no, let's keep going. So I have 12 equals x over x minus 2. Now we have a problem because x is in the denominator. I don't like that. So let me just make a little note to myself that x cannot equal 2, right? Because I can't divide by 0. And now I'm going to cross multiply so that this denominator is now not in the denominator. So I'm going to do 1 times x and 12 times that binomial. So 12 times the binomial gives me this, and 1 times x gives me this. And now I just have to collect like terms, subtract x from both sides, add 24 to both sides, x equals 24 over 11. And because I started with a log statement, I'm just going to go back to the top and double check what my restrictions would have been. So I can't let x has to be greater than 0 based on this guy. X has to be greater than 2 based on this guy. So let's see. 24 divided by 11 is greater than 2. So our answer is good. Yay! All right, so I think that was all I said I was going to do in this video. Yep. So in the next video, I will answer the rest of this question. Hope that's been helpful.